In these examples, we're looking at division of terms which involve indices. So here we have g to the power 5 divided by g squared. And often when we're dealing with division, it's much easier to write it as a fraction, so g to the 5 over g to the 2. And the reason why that's easier is because we can expand each line and have a look at doing some simple division. You can see here in the top line that we've got g to the power of 5, so we've got 5 g's being multiplied out, and in the bottom line 2 g's being multiplied out because it's g squared. And the red highlights the g's that are common, so when you're doing division, 1g divided by another g is 1. So what we end up with is a case of g multiplied by g multiplied by g. The g's in blue is what's left behind, and that's g to the power 3. In this example, it's another division, and it's already expressed as a fraction. So we've got 10 a to the power 2, b to the power 3, all divided by 5ab squared. We can expand that, so the top line is 10 multiplied by a, and then we've got the 3 b's all multiplied out because it's b to the power 3, and likewise we can expand the bottom line. Now if we look at the colours there, we can see that the whole numbers are in red, 10 and 5, and there is a common a in green between the top and the bottom line, and there's 2 b's that are common between the top and the bottom line. So we're going to remove the common a's and common b's, because when you divide by those you're only left with 1, and the whole number 10 and 5 we can do like a normal division. 10 divided by 5 is 2. So that leaves us with our final answer that we can see there in the bottom line. 10 divided by 5 is 2, and we've got the a and b left over in the top line. So just a bit of a review of what we've just done. If we have a look at some other examples here, if we do g to the power 4 divided by g squared, we're left with g to the power 2. Likewise, if we look at the powers in the k's and the m, k to the 4 divided by k squared gives us k squared, and m to the 3 divided by m to the 1 gives us m squared. It appears as though the rule is saying that if there's a division of terms which have a common base, you can subtract the indices. 4 take 2 is 2, and 3 take 1 is 2. So it appears as though common bases means that when there's division, you can subtract the indices. Let's have a look at this mixed example which involves multiplication and division. So recall some of our rules from before. When you're multiplying and there's common bases, you can add the indices. So that means that if we split all the top line up, we can look at the g's and the h's separately, and of course the whole numbers there in red, the 3 multiplied by 8, and apply the rules of multiplication. 3 multiplied by 8 in red is 24. With the g's in green there's a common base, so we add the indices. 3 plus 1 is 4. And with the h's in purple, we can add the indices 3 and 2 to give us 5. Now with division, if we apply the rules of division with common bases, the concept is that we subtract the indices. So looking at the whole numbers first, we just do a normal division. 24 divided by 6 is 4. g to the power 4 divided by g squared has a common base, so we subtract the indices. 4 take 2 is 2, and with the h's we have a common base, so 5 take 4 is 1, and the result means h to the 1, or just h. We don't need to write the power 1 there. So our final result is 4g squared h, by applying the rules of multiplication across the top line first, and then the rules for division after, to get the final answer.